Hi, in today's video, we'll go over different measures of central tendency. Now, the first one you've probably all seen is the sample mean. So the sample mean of a variable x is just the average value of that variable in a given sample. And the formula for the sample mean is x bar is equal to x1 plus x2 plus all the way to xn divided by n. Okay, and very often it's represented as x bar in the literature. Now, this sum, x1 plus x2 plus x3, etc., can be represented in this form. Okay, this is the summation notation. So you have sigma, the Greek letter, and here I is equal to 1 at the bottom and n at the top. And that means that the xi that you see here will go from 1 to n. This is exactly what we see on this part of the equation. We have x1, x2, x3, etc., all the way to xn. And now it's divided by n, okay, where n is the sample size. So this is what you've probably all done when you were trying to calculate the average grade that you had in a module. So you just add up the grades and you divide by the number of exams you took. Now, the second measure of central tendency that you may have come across is the median. And the median is just the middle value in a series of values arranged from smallest to largest. So what does that mean? So to find the median, you first need to order all the values from smallest to largest. And then if there's an odd number of observations, the median is the middle value. And if there's an even number of observations, the median will be the mean of the two central values. So let's see an example to make that clearer. So let's look at sample A. So we have different observations. So 1, 2, 4, 7, 9, 13, 18, 20, and 33. And we need to find the median. So as you can see, they've already been ordered from smallest to largest. And now we just count the number of observations. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So there are 9 observations. So that's an odd number. So we can just see, well, here, if I put 4 observations on the left-hand side and 4 observations on the right-hand side, the middle observation is exactly 9. So here, the median is 9 because the sample size is odd. Now, in sample size B, there again, everything is ordered from smallest to largest, but now the sample size is even. I have just added 77 at the end. Now, when that's the case, there's not a single observation right in the middle, okay? Because if we try to get the same number of observation on either side of the median, well, we can see that the only thing we can do is say, well, here we have 5 observations and here we have 5 observations. But there's nothing here. So what we're going to do is just take the average of the two values that are basically in the middle. So the median is 9 plus 13 divided by 2. So that's how we calculate the median. Now, the median is really a particular case of what we call percentiles. And a percentile is the value below which a given percentage of observations fall. Now, if you think about the median, it's really the 50th percentile, okay? Because 50% of observations fall below the median. Now, if I take a different example, the 20th percentile is the value below which 20% of the observations falls. And now there are different terms that statisticians tend to use, and it's basically, so different types of percentiles have special names. So the 25th percentile is called the first quartile, sometimes referred to as P25. Now, what would be the second quartile, as P50, is really the median, as we've just discussed, okay, because 50% of observations fall below that value. And the third quartile, P75, is the 75th percentile. So that means that 75% of observations are below that value. Now, a third measurement of the central tendency of a given variable is the mode. And the mode is simply the value that occurs most frequently. When the data is grouped in class intervals, the mode is just the midpoint of the category with the highest frequency. And when the data is continuous, it's usually preferable to group the data in class intervals before calculating the mode, okay? And one thing to really keep in mind is that there can be more than one mode. So let's have a look at some examples. So let's look at sample A. And once again, I've ordered the sample from smallest to largest. And now we just count the number of times each value occurs. And we can see, well, 1 only occurs 1, 2, same thing, 4, same thing, 5 occurs twice, 9 ones, 13 ones, 18 3 times, 20 once, and 33 once. So the mode is 18 here. Okay. So that's a relatively simple case. Now, let's imagine that we have a variable that is continuous. Okay, so let's say height would be such a variable. Now, every single observation could have a different value, especially if you measure it really precisely. And so here we see that, well, 1.2 occurs once, 1.3 occurs once, 1.4 once, 1.5 once, 4 occurs twice, 5.8 once, and 8.4 occurs once. So if you just took this at face value, you would say, well, the mode is 4 because it occurs twice, whereas all the other values only occur once. But now, if we look a bit closer at the data, we can see that there are a lot of values that are between 1 and 2. Okay, so there are 4 of them. And there are only 2 values that are exactly 4. So if we grouped the data in class intervals, let's say from 1 to 2, from 2 to 3, from 3 to 4, etc., we would find that the most common category is between 1 and 2, because you have 4 observations that fall between 1 and 2. And so then to calculate the mode, you would just take the midpoint of that category, and so that would be 1.5. So whenever you have a continuous variable and you're interested in the mode, remember that it might make sense to group your data in class intervals before calculating the mode. So that's it for today's video, and in the next video, we'll see in which circumstances each one of those 3 measures of central tendency makes the most sense.